It is lesson 8. It's a sunny but cold Thursday. We've just done a quick midterm review, and we're going to dive into lesson 8. So we're going to go over assignment 3, which is now posted to Blackboard. So in assignment 3, you're going to be extending assignment 2 by implementing security measures. So the mark counts for 10% of your grade. You have 2 weeks to do this. This won't take very long. It should not take you longer than about an hour to do this. 1 to 2 hours. So 13 days is plenty of time. To submit on Blackboard, you can just submit the same repository link and Azure link that you used for assignment 2. If your Azure credits have expired, you can also use this service. I'll put the link in the chat as well. One of the students in my Tuesday section discovered this, smarterasp.net. They will give you a free 60-day trial. It will give you a database, so you can always deploy your assignment here for free. You do have to upload it with FTP the way you would have done in your PHP class. It doesn't support the continuous Git integration like Azure does. So you're going to do your own work on all of this, and your submissions are subject to a code review. So you're going to implement both local and social authentication. Local meaning username and password in your SQL Server database, social authentication using a third-party social media provider. So in your project, in the Startup CS, you are going to disable the account confirmation emails for new registrations, much like we did in class in our pet store. You're going to register a new account for me with this username and this password. So this way I don't have to register on 35 websites. Please go ahead and create the account for me so I can just log in with it. You're going to make the views, any views where users can add, edit, or delete, private. So only an authenticated user can reach them. On the index views, anonymous users should be able to see the data, but they will not see the links to create, edit, or delete. You're going to enable Google authentication. We're going to do that with our pet store today. So that's going to involve some configuration in the Google Developer Console, and then some configuration and a small amount of coding inside your project. You will commit regularly to GitHub and publish your site to Azure Smarter ASP and include the link in your README file. Okay, so the assignment's out of 15, 8 marks for implementing the authentication model. So a user must be logged in order to add, edit, or delete. 4 marks for Google login, a couple marks for GitHub and server deployment. Now I'm only asking you to implement authentication here. So there's really 2 types of users. There's anonymous users that can only see your data, and there's authenticated users that can change it. You do not have to implement authorization, like different rules and permissions. That is not required. I know we've implemented authorization in class, in the pet store. You don't have to do it for your assignment. If you want to use authorization, if your site you think requires it, that you want to have different levels of users, you are allowed to do it, but you do not have to. No, Jordan, it's not. It doesn't have to be. You can ignore that requirement because you might do this. In fact, I gave this out Tuesday. I looked at the Dropbox, and one of the students on Tuesday, she's already submitted and done it. And I just gave it out. In fact, I will show you a sample. If I think I can find. I think this is her GitHub. I will show you. Link. think I can find the site here. Okay. So as an anonymous user, I can see data, but I have no ability. I don't see the links to add, edit, delete. And if I try, let's say, to create, I'm asked to log in. She's set up an account for me. And once I log in, now I can see the links and I have access to now go to add, edit, delete. So as an anonymous user, I can see the data, but I have no access to add, edit, or delete. Once I'm logged in, I have these. She's also implemented Google authentication, so I can also log in with a Google account. Got a Google account here. And again, once I'm logged in, I have access to add, edit, delete. As soon as I log out, my views are read only. So this is what I'm looking you to implement this functionality, implement this into your assignment 2. So yes, it's fair. Don't worry about making your commits over 2 separate calendar days or 4 commits. I just want to see that you're using GitHub. 4 commits may be more than you need to make. That's fine. I won't penalize you for that. Does anybody have any other questions about the assignment and the requirements? 13 days is lots of time to do this. Okay. Anybody else? Any questions? Okay. Thanks, Raymond. All right. Okay, so we want to do a few things today. It's our second class on authentication. So one of the important things we should talk a little bit about and how it's integrated into our ASP.NET project is SSL. So if you follow this link here on Blackboard, put it in the chat as well. Excuse me, you can log in to the Padlet site with your Georgian Microsoft login. It'll take you here. Whoops, hang on just a second. Delete some stuff. I thought I did. So I'm going to take a minute and add a sticky note with your name, telling me what do you know about SSL. Let's go here and sign in. There's a little plus button at the bottom where you can add a sticky note. So add a note with your name. I'll pause our recording for a couple minutes. All right, this is great. Seeing some really good answers. So we know that SSL, Felix said, it stands for Secure Socket Layer. So it's an industry standard technology allowing for more secure transfer of data between two different entities on the internet. And as many as people like Ralph and Jake mentioned, what it does is it provides encryption. Okay. Normally, HTTP, all of the messages that go back and forth in HTTP, they're sent in plain text by default. So when you enter your username and password in a website and submit a form, and it goes from your computer to your ISP and then to the web server's ISP with many stops in between, all that traffic travels unencrypted by default. So when we add SSL to the website, it will encrypt any of that traffic that we send from our device, but also it encrypts any traffic that comes back from the web server. So that might include things like your bank account numbers and your transactions and your bank balances. So we want all of that traffic to be encrypted. Now, I have one note on here that says we need SSL for every website, even if it's just static HTML and there's no sensitive data at all. How come? Why do you think we should have an SSL certificate, even if there's nothing particularly sensitive in the website? There's a few reasons we should still use SSL. Can you think of any reasons to use SSL? Let's say you're just building an HTML, CSS, JavaScript website. There's no logins. Okay, yes, David, that's a good point, right? That's one. So you'll notice, right, that our browsers, they give a little indicator that our site is verified. We can see the HTTPS here. We can even go and look at information about the certificate. When does it expire? What type of encryption is it using? Kind of encryption algorithm. So any site without HTTPS, your browsers won't have the lock here. And it might say in Chrome, it even, I think, says not secure. Looks something like this. You've probably seen it. So Chrome will show any site without SSL. It'll show it as not secure. So that's going to scare people away. Other browsers will do it as well. Or it'll just say not secure here. Not ideal. Why else? So that's a very good reason. Can you think of any other reasons kind of related to that? And thanks, Mike. Yeah, it uses a cryptographic key pair with a public and private to verify the identity of the site. Yeah, Colton, can you explain? Absolutely, it affects SEO. How does it affect SEO? It definitely does. You got it. SSL implementation is a factor in Google's ranking algorithm. So sites that don't use SSL are going to rank lower. They're going to be further down in search engine results than sites that do. There's also just a case of professionalism. In 2021, educated users will expect that their browser is going to mark every site as secure, that it will show with HTTPS. That's a good point as well, Felix. Yes, it can reduce your ad quality score if you're bidding in advertising campaigns. I actually wasn't aware of that, but that makes sense. So even if there's no sensitive data on your site, if you want people to be able to find it, if you want your browsers not to mark it as not secure, you need an SSL certificate. And it's our responsibility as web developers, we're typically responsible for buying and installing and making sure that our certificates don't expire on the sites we build. And as David mentions, we can always see with the HTTP and HTTPS. This also means that we want to ensure that when we install an HTTPS, an SSL certificate, that all the requests are sent through it. So if I try and go to our Padlet page, but I take out the S, I try to go to the plain text, the unencrypted version of this URL, notice it just redirects me back here. Be the same thing if I try to go to this page in Blackboard, if I take out HTTPS, just redirects me back. So there's a check making sure that all requests get filtered through HTTPS and that they are encrypted. Now, there's a few different ways you can get SSL certificates. I'm going to show you some of the options. Some hosting companies, many times the easiest way to get an SSL certificate is just buy it through your hosting company. Now, there's a benefit and a downside to this. The benefit is the hosting company just takes care of all of it. You just say, I want an SSL certificate for mydomain.com. You pay the fee, they'll install the certificate. So that works well with sites like, let's say, GoDaddy. So if you're hosting a site here, the good news is you can just request an SSL, you pay for it, they install it. It's done. The bad news is GoDaddy SSL certificates start at $85 a year, which is expensive. I mean, it's cheaper than they used to be. When the first SSL certificate I ever bought, almost 20 years ago, the cheapest one I could find was $300 a year. Now, your clients, you pass that cost on to the website owner, but typically we pay it and then we bill our clients. So on GoDaddy, this is the only option you have. You can only use their $85 or more certificates. Some web hosts will let you install your own certificates, and you've got a few options. I buy certificates oftentimes from Namecheap, which for 1 year start at $12 a month, so much less expensive. However, if you buy one of these, you have to do a lot of the work in getting your hosting company to install and configure it. If you buy the ones from GoDaddy, they just take care of it all for the $85. So they have some different levels of encryption, different kind of warranties on a number of these. The cheapest option, which more and more web hosts support, but not all of them, is called Let's Encrypt. So Let's Encrypt is a not-for-profit that offer free SSL certificates. So some of the hosting companies where I host some of my client sites, they support Let's Encrypt, and I can just enable it by clicking a button, which is great. A hosting company like GoDaddy, they won't let you use this. They will force you to buy one of their certificates. So what kind of certificate options you have are going to depend on where you are hosting your website. And sometimes as the web developer, you can decide where you're going to host. And other times your client will already have a hosting plan somewhere and they'll tell you this is the host you need to use. So you'll need to investigate what kind of SSL options are available to you. So I've used all three of these. I have some clients that host on GoDaddy and they pay this annual fee. I just make sure the certificates get renewed every year. I have some where I look after their hosting and I can buy these cheap certificates. And I have some clients who their hosting is with companies that support Let's Encrypt. So their SSL is free. So why are we talking about this? Who cares? How is it related to what we've been doing with ASP.NET? Well, let's have a look. In our project, when I run the pet store, you may remember that when we set up the project, there was a little option to enable HTTPS. And I encouraged everybody to check it off to make sure that even locally our site runs with HTTPS. Now, we have a self-signed certificate. It's not issued by a verified certificate authority, but we do have our own self-signed certificate, so all our pages run under HTTPS. When we check that box, it actually does a few things in our project, which we haven't really looked at. I'll just show you the implementation. By checking that box in our startup file, down here on line 56, we've got this use HTTPS redirection. So this is what forces all requests. So any request that comes through on plain HTTP, it's going to get redirected to the HTTPS, going to get redirected to the secure version. So we can see this redirection on Azure. If I go back to Yulia's demo site, what was it called? So we can see on Azure, we're using Azure's SSL certificate. So our site runs on HTTPS. If I take out the HTTP, it just redirects me back. So that's what this line of code in our startup file is doing. Automatically redirects plain HTTP requests to the same URL, but with HTTPS. And if I go to my project and look at the properties within Visual Studio, on the debug tab, you'll notice there are two URLs here. There's an app URL that runs on plain HTTP. Now, we don't use this one because we set up the project to run under SSL. It runs on this address instead, HTTPS, localhost, and then all of our port numbers for all your projects, they're always going to start with 443. That's the default in Windows for SSL. So the last two numbers will be different. My project runs on 44338. Your Positive Pet Store will run under 443, and the last two digits may be different. Every time we create a project in Visual Studio and we enable SSL, it's going to run on 443 and it'll randomly assign the last two digits. So we have 100 spaces for different HTTPS projects in Visual Studio. One thing you will note, I also mentioned here with Azure, is on smarterasp.net, our alternative. So I've signed up for the free trial. Their free trial does not actually include SSL. So your site won't run under SSL here. Something to note if you have to move from Azure over here. They have SSL, but it's not free. You have to pay for it. So if you migrate your site over here, it won't have SSL. Don't worry, I'm not going to penalize you for that. It's just for your assignment, but that's something you should be aware of. Does anybody have any questions about working with SSL? All right, so let's carry on then. With our pet store. So this is where we left off. So if I go to the register or login page, we've got a form on the left of each page, and then we have this message on the right under this use another service to register, and it tells us there are no external services configured. So this is on our register and login form. So what we're going to do is we're going to configure and then implement Google Sign-In together in our pet store. So I'm going to give you a quick walkthrough of how we're going to do this. So there's several different login providers available. We've got Google, we've got Microsoft. So Google we're going to implement together, and then Facebook you're going to implement on your own or with a classmate or two as a lab. So there's a full tutorial here. And it's actually the same link. Microsoft was nice enough to even link directly. Should open it in a window, new tab. So they've given us a tutorial right from creating a brand new project. We can kind of skip that stuff, but it explains, goes through how to set up Google or Facebook authentication. So we're basically going to go through the Google example together, and then you can use that same link for some guidance on how to do the lab. It's about 90% the same, the Facebook integration, the Google integration. There are a few small differences. So I'm just going to kind of give you a walkthrough of what we're going to do. This will just take a few minutes. We'll take a break, and then when we come back at 12 o'clock, we'll actually walk through the Google implementation together. So we'll have to go to the Google Developer Console. You'll have to sign in with a valid Google account. We're going to create a new project. And then we're going to go through the steps, about 3 or 4 steps. We're going to need to configure a consent screen. So it's going to ask us what kind of Google account are we going to allow in? Internal, meaning only people within our organization, but we don't have an organization. Or are we going to let any Google account in, so an external user? So we're going to pick that option. We're then going to get a pop-up window where we have to configure the name of our application as well as an email for support. The rest of the stuff we are going to leave blank. We're then going to create a set of credentials, an OAuth client ID, which will request Google user consents so that our website can access their Google profile. We're going to need to pick the application type, which will be web. We give it a name, which we'll probably call Positive Pets, matches our project name. And then we've got to enter redirect URIs. So what Google needs to know is, once somebody signs in with Google, Google needs to know where is it supposed to send the user back to. And it's going to be our local domain or our Azure domain, followed by /signin-Google. This is the URL that we want Google to return those users to. And we're going to install a library that will automatically redirect the users if they log in successfully with their Google account. And then once we're done setting all this up in the Google console, it's going to give us a set of API keys that it calls the client ID and client secret. And we're going to need to include these 2 values in our Visual Studio project. So we're going to store them, for simplicity, we're going to store them in our appsettings.json file. There is another option which we'll talk about. Windows has a secret key vault. And then we could also use the Azure configuration section. We're not going to do this method. This is more secure, and this is what's recommended best practice for a production level application. But many people don't have access to Azure anymore. So we're not going to do this. It'd be too difficult for too many people. So if we just store them in appsettings.json, it will work locally and it will work when we deploy to the web server. But keep in mind, this version, your app settings file, this plain text is not encrypted. So I've explained using the Windows Key Vault, but we're not going to, and the Azure configuration section, but we're not going to use that process in class. We'll then have to install the authentication library for Google, for .NET Core, and then add a bit of code to enable the Google sign-in and use the API keys that we're storing. It's then going to change our register and login forms automatically. So this message that we see here on register and login, it's going to disappear, and we're going to have a Google button instead. We click it, we're going to get taken off to a Google sign-in screen. And after we authenticate with a Google account, we'll get a page looking like this after, saying we've successfully authenticated and confirming the email address of our Google account. And then it's going to create the user, not only in ASP.NET Users, but it's also going to create a record in ASP.NET User Logins, where it has our user ID and then the Google provider. So we'll know that this user, they are signing in through their Google account. So we will go through this whole process together, and these slides are available for you to reference because you'll need to do similar process in assignment 3. They're right here, the lesson 8 slides, as well as the link to the tutorial. It's here as well. Okay, so that was a bit of a preview of what we're going to do, and we will walk through these steps together to integrate that Google sign-in into our pet store. So my clock says 11:50. My voice needs a bit of a break. I think we all need a bit of a break. I'm going to stop the recording. I'm not going to put anything on GitHub because we haven't made any changes yet. We will start our Google integration at 12. So let's take a 10-minute break.